By the way, if you spill super glue on your nice white workbench, acetone will clean it up beautifully. Just in case that's a concern. Welcome back to Cloud 42, I'm James. Well, today we're going to start on a new set of enhancements for my benchtop lathe. We're going to put on a Multifix Toolpost, and while we're at it, we're going to delete the compound and replace it with a cast iron riser block. And when I say cast iron, I mean we're going to cast a riser block. Now the first step is going to be to figure out exactly what we need, design something up, and make a 3D printed pattern so that we can have the part cast. This is the quick change tool post that I have had on my lathe for several years. This is an Elegoo style, this is an A size quick change tool post. This one is actually made by Shars, but you can buy these from a bunch of different sources. There's also a style that instead of having this sliding dovetail has a plunger that locks the dovetail. But in any case, the tools are just put in tool holders with the same dovetail geometry, and they just drop on and lock in place. And then for things like boring bars, there's another dovetail 90 degrees away, so you can put a boring bar on the front of the tool post. And then if you need a different angle, you of course then have to unlock the locking bolt, rotate the tool post, and get it aligned somehow, either by dialing it in or pressing it up against the chuck to put it into a different position. Now, don't get me wrong, this is a great tool post. It has served me well, and I could continue using it. It works just fine. However, I've always been intrigued by the Multifix or the 40 position tool posts that are out there. I've seen a number of them on other lathes. I've never had a chance to use one, but I've always wanted one, and I finally picked one up. Let me get this out of the way. This is the size A Multifix tool post. This one is from Pee-wee Tools in Germany. I emailed Peter at Pee-wee Tools and we talked a little bit about what size is appropriate for this lathe. He's got a whole range of sizes, and there are 2 or 3 that technically could fit on the machine, but after looking at all the dimensions, I decided that the A size was probably the best fit, so I went ahead and ordered it, and now that I have it here, I agree the A size is really the best fit for this lathe. The biggest issue for this lathe is that the distance between the top of the compound and the center of the spindle bore, which is the same height as the tailstock, it's pretty short, and so squeezing tools into that space so that they fit over the top of the compound and can still hit the center line of the workpiece in the lathe is pretty difficult. And so if you end up with a tool post that's too large, you just cannot get the tools low enough to fit. And with the A size tool post and the typical tool holders that come for it, this is the AD1675, and I think I've got 8 of these in the box along with some others for different tool types. This ends up being just about the right height so that I can get 1/2-inch tools on center in this lathe. With the Elegoo tool post, I really could only use 3/8-inch tools. I really could not get the 1/2-inch or 12mm tools low enough to get the cutting point on center. This is a 1/2-inch tool, and the geometry here actually works out great. Now, if you haven't seen these tool posts before, you'll note that as opposed to the Elegoo that has 2 positions that the tool holder can go in, this has a whole bunch of teeth in it, and the clamping shell actually rotates around with the this center post attached firmly. I don't have it attached yet, but attached firmly to the machine so that you can have your tools set up, square 90 degrees to the workpiece. I don't have this bolted down, so it's hard to get this snapped into the right position. Or you can rotate this to any of 40 different positions and drop the tool precisely in at that angle. So that then when you say, okay, now I'm done, I want to come back to square for a facing operation or turning operation, you don't have to fiddle around with it and adjust it. You just turn it back and it will drop onto the teeth precisely and repeatedly back at that 90-degree position. And that's the real win with this tool post, is you can quickly change the angle of the tool, and then you can quickly change it back and know that you're dropping it down square and you don't have to adjust anything. Now, in addition to putting the new tool post on the lathe, I would also like to get rid of the compound and replace it with a solid riser block. Now, this particular compound on this lathe is notorious for being flexible. It's held on with 2 studs and a thin steel clamp that holds the base of the compound down to the machine. And the whole system is flexible enough that if you watch some of my old videos, when I'm taking a heavy cut, you can see the whole compound tip forward, and you can see the tool dive below center when it enters the cut, and you can see it pop back up when it leaves the cut. Obviously, you can get away with it. I've done it. But the whole experience of using this machine will be much more satisfying, and the machine will be much more rigid and much more capable if I can solve that flexibility problem. And the common solution that you see is to take off the compound and replace it with a block of cast iron. And that's, in fact, exactly what I'm going to do. Let me get the compound off of the machine. You'll note that this cross slide doesn't just have the 2 holes to hold the compound on, it has an additional 4 threaded holes. And I put those in when I had these parts off anyway to mount the DRO. And you can see that in the previous video. In the first DRO install video, I actually went ahead and drilled those holes because I already had this in the machine. Now, I want this block to be pretty wide. In fact, I want it to be about 4 inches wide front to back. And the reason for that is the whole point of this is to make it stable. If I came back in here and made something really narrow that just fit into the tool post, well, then I'm counting on the rigidity of this cross slide, which is probably pretty good. But as long as I'm putting a block of something on here to make this thing more rigid, we might as well make it nice and wide, have it angled down away from the tool post for clearance in the front, and build something that is just going to be rock solid. There'll be no question about it. So I want that to be about 4 inches. The width of the slide is just over 5 inches, and the height that I need in order to get this up to the right place is just over 2 inches, like 2 1/8 or 2.12 or something. That's a big piece of cast iron. And the normal extruded or continuous cast gray iron that you can find like Durabar typically comes in sizes up to 2x4, but 2 inches isn't high enough, so I need a bigger piece. And by the time you find a piece of cast iron that size, you're talking about real money. In fact, I'm looking at prices of $200 to $250, at least where I live. So as long as we're talking about that kind of money anyway, it really makes sense to just go ahead and have the part cast. So I talked to Clark Easterling at Windy Hill Foundry, and he has the capacity to get the job in for me. So all we need to do is make a pattern, send it to Clark, and he will send us back a nice cast piece in gray iron. To make the pattern, I want to 3D print it, so let's go into the computer, design up a tool post riser that we're happy with, and then make a pattern from that, send it off to Clark, and hopefully get something back in a very nice piece of gray iron. Here in Fusion 360, I'm going to start with a model of the cross slide for the lathe. And you can see that this model of the cross slide already has the 6 holes in it, including the 4 that I drilled in a previous video. Now, I chose the locations of these 6 holes based on the needs of a 6-bolt compound clamp, which is something that I may still do for this lathe. But for now, I'm going to design a solid tool post riser that uses those same 6 holes. So I went out to the internet and found a model of the Multifix size A tool holder. I believe this one came from GrabCAD. I think there are a couple of them out there, but this one I pulled down, did some measurements of it, and it looked pretty good. So what I'm going to do is I'm going to take this model and I'm going to put it in space relative to the cross slide where I want it to be, and I'm going to do that with some joints. So I will say joint here, and I will choose a point on the bottom, choose a point here on the top of the cross slide, and I want to space this up the correct height. And the correct height is 2.188 inches. So that's what I actually measured, and for motion, I want to make this a planar joint. So all it's going to constrain is the height. It won't constrain any of the other motion. So this can move around, but it's going to stay 2.188 inches above this. So I'll do exactly the same thing again and constrain it with a couple more dimensions. So say assemble, joint, and I'm going to choose this surface, and I want to flip that so that it's the correct position there, and I want exactly the same planar fit. So this is just going to stay, it's going to constrain it so that the edge of that tool holder is in the same plane as the edge of the cross slide. And so now I can still move in this direction, and I want to do the same thing. I can hit J for joint, pick a point there, pick a point on here. Now it wants me to anchor it. And again, I'll need to flip that. And we can simulate the motion. This is planar, so this is going to constrain it so that the back edge of that tool holder is coplanar with the back edge of the compound. Click OK, and now this whole thing is anchored in space. So I've got the slide here. I previously came over here and said ground, so you can see the pins there on the slide. So the slide is anchored in position, and now the compound, or the tool post is in position above that. So now we can model the actual riser block. And I want to do a couple of things. I've already set up some parameters in here. So I want to make the base thickness 0.9 inches. I've got that in here as a value. I'm going to use a standard draft angle of 3 degrees. And the reason I'm going to go with 3 degrees is to make it so that the pattern can be easily extracted from the sand mold. 1 or 2 degrees is probably fine. I want to make this as easy as possible. I'm not trying to set any records for precision. So we'll start with 3 degrees. And then I also have a value in here that is the pattern shrink per foot. So talking to Clark at Windy Hill Foundry, he told me that he works with a standard shrink for the cooling cast iron of 1/8 inch per foot. So I've got that in here, and then I've got the math to calculate that out as a ratio, and it ends up being just barely over 1%. So let's start by modeling the base of the riser block. So I'm going to construct an offset plane, and I'm going to bring this up the base thickness above the base here. So there's the plane I just created. That's up my base thickness, which was 0.9 millimeters. And now I'm going to create a sketch on that plane, and I'm going to project the entire top surface of the cross slide, so I have that geometry to work with. And now I'm going to come up here, and I'm going to create a center rectangle starting from the center here, pulling it out to this corner. So that gives me a rectangle that will meet up with the edges of the cross slide, and I happen to know that this bolt hole pattern is centered around that center pivot hole in the cross slide, so I know that this is centered on my hole pattern. Now I'm also going to put another rectangle around the outside of this, and we'll talk more about what that's for later. I'm just putting it in this sketch so I won't have to create it later. So now I can come in here, select this region, and in fact, I'm going to hold control, and I want to select everything in here. I probably should have made these dotted lines instead of solid lines, but you know, it is what it is. Okay, E for extrude, and I'm going to extrude to object down to the top of the cross slide, and I'm going to say new component because that's what I'm trying to do. And in addition, I want to taper this, and the taper angle will be the draft angle. And so that's going to come down and taper out by the draft angle. Great. Now that gives me the base that's going to bolt down to the cross slide. Now I want to make the pedestal that's going to support the tool post. So I'll come up here, right click, create a sketch. I'm going to project this circle into it, and I am going to make that a construction line this time. And then I'm going to hit O for offset, and I'm going to offset outside of this maybe 3 millimeters, and I want that to be solid. There you go. I mixed inches and millimeters. Everybody should be happy now. Okay, so now I'll select that, hit E for extrude, and I'm going to do the same thing, distance to object. We're going to come down to the top of this. Now I'd like to taper this out a little bit more for aesthetics, and I'm going to taper that maybe 5 degrees, no, 10 degrees. Sure, that looks good. And again, I'm just imagining what this is going to look like when I smooth out all of these edges. Okay, so that is the rough geometry. Now let's smooth it out and make it kind of organic. So I'm going to hit F for fillet. We're going to pick this edge, and let's pull up some curves. And how far can I go? Looks like I can go to about 2 inches before the whole thing degenerates. And I do like the look of that. Okay, so there's 2 inches there, and then let's go ahead and put some more curves on some of these corners. Just going to select all of these edges here, and let's say 1/4 of an inch. Yeah, that looks good. And hit F again. Let's do this top edge, 1/4 of an inch. Okay, now that is a shape that I can get behind. I like that. Now we need to put in some holes for bolts that will line up with these threaded holes. So I'm going to go back to this sketch that I created before. Is that the right one? Yep, that's the one. And I'm going to turn that on, and then we're going to go up here and use the hole tool. And I'm just going to select those 4 points for where I want the holes. And I want a counter bore. I want it to be a clearance hole. Okay, so now I can come down here. Metric, these are M8. And so there are standard M8 counterbore holes. 1 inch deep is fine because we know you only have to go through 0.9 inches. Now notice that the heads of these are actually below this top surface because I'm taking these down from the base thickness of 0.9 inches that I started from. We'll fix that momentarily. Okay, so now those screw holes are in there, but they're actually down inside. If I do a section analysis, say inspect, section analysis, and cut a cross section, you can see that those are in there, but they don't extend through the top. We're going to fix that right now. Okay, so let me turn off some of this stuff we don't need. Let me turn off the cross slide and the gib, and that will allow us to reach up inside and select those top undersides of those holes. I'm holding Control and clicking just so I can select multiples, and then I hit E for extrude, and we'll just pull those up through the top with cut, and now we have our nice clean counterbore holes through the part. Now the last thing that I want to do for the construction of the riser block itself is we've got this draft on the side, and that'll be great for casting this part, but I do want to machine that off. So we'll come back once again to this sketch. I'll select this region, hit E for extrude, distance to object, we'll bring it down to the bottom here, select cut, and that will machine off those sides. So we'll actually cast it with the draft on it, and then we'll come back later when we machine it and clean up those edges. Give this thing a name. That is our riser block, and that is pretty much all we need for the design of this thing. There will be a threaded hole in the top for this bolt to hold down the tool post, but other than that, that's all we really need. Now that we have this part designed, let's turn it into a casting pattern. So for casting pattern, we're going to need to make sure we've got the right draft on it. We're going to need to make sure that we have additional material where we need to machine off, and we're going to need to scale it up. So let's go ahead and do that. Let me just go ahead and turn off the other things here that we don't need. Now, for now, I'm going to suppress this machining feature. So I will right click and say suppress feature, and that will give us our draft angle back. Now the pattern is also not going to have these holes, so I'm going to go ahead and just start selecting these surfaces and hitting the delete face key, or hitting the delete key. So select, delete, and you can see I'm just selecting the shoulder here and then the bore, and Fusion will do a nice job of just deleting that entire screw like it was never even there. Now, why did I put it in and then go back and delete it instead of going back and suppressing it? I'll show you that in a minute, but it's essentially so that I can work with rolling the history back so I can have 2 versions of this model. Now, the top and bottom of this part are going to be machined flat after casting, so we need to add some additional material. So I will click the top, control click the bottom, and right click and say press pull, and we'll pull that out 0.1 inches, so that'll add an extra 100 thou of material on the top and bottom, which is sort of a standard machining allowance for cast iron. And then we can't have these sharp edges on it because those will end up chilling, cooling too quickly in the mold, and hardening. So we'll hit F, come back, select the top and the bottom, and put a 0.1 inch fillet. And that is the basic shape of the casting pattern. The last thing we need to do is to scale it up. So I'll go into here and say modify, scale. I will select the body, and scale type is uniform. Scale factor is going to be, what did I call the parameter? I called it pattern scale. So modify, scale, choose the body, and scale it up by the pattern scale factor. So that makes it just ever so slightly bigger. It's about 1% bigger. And now this is the model that we need to 3D print in order to make a casting pattern. Now we could split this right along this line here at the edge of that fillet, so we'd have a two-part pattern. So we would put this in the bottom half of the mold, and then we'd put the split other half of the pattern on the top. So this would go in the drag, this would go in the cope, but there's really no point in that. I talked to Clark about it, and he said it's no problem just to make a one-piece pattern, sink this in, and then he'll come back and actually just cut down to the tangent line and then mold the other half of the mold over the top of it, and he should be able to sand cast this directly. Now, the reason that I constructed this the way I did and ordered this the way I did is that now, if I want to switch back and forth between the casting pattern and the actual pattern for the part, I can come down here and drag my history right back to this suppressed feature, and that will take away everything we did for the pattern, and then I can unsuppress this one machining feature, and now we have a model of the tool post itself. So I can 3D print this tool post model, and in fact I can put all of the other parts of this model back so I can see how it's going to work and make modifications to it. And then when I want to actually do the 3D print for the casting pattern, I just drag this out and suppress that one feature, and now I have the casting pattern. It would be really great if Fusion 360 had different configurations. I would do this in a tool like SolidWorks by creating configuration branches and turning these features on and off in those branches. I don't believe Fusion has that functionality yet. I would really like to see it, but it's not there. Now, for the actual pattern that I'm going to use, I went ahead and added raised text. And I'm not going to do that in this video. Doing text like this on a curved surface with proper draft angle so that this will pull out of a sand mold was extremely challenging. If you've seen any of my previous videos where I struggled with three-dimensional text like the pantograph font, this is 100 times worse. And you can see I have got all kinds of face delete features down here in the timeline. It was a real challenge to make this happen. That might be something that would be the subject of a video in the future, but I'm not going to go into all of that pain and suffering today. Now, the one other thing that I put in the final pattern is a 5/16 18 threaded hole here in the bottom that is centered right over the center of mass. You can see here that Fusion 360 calculated for me, and that is for a pull rod so that when this is sunk down into the sand mold, you can thread in a rod, tap it, and easily extract. So if you use a nice long rod, since it's right through the center of mass, this pattern should pull cleanly straight up out of the mold. So now that we have both of these designs for the casting pattern and the finished machined part, I'm going to go ahead and 3D print a representation of the finished machined part, and we'll take that out to the lathe and use that for some test fitting. And assuming that all looks good, then we'll go ahead and 3D print the casting pattern and get that sent off to Clark so he can turn it into cast iron. Now, before we go and spend a lot of money getting something cast, it makes sense to do a quick sanity check. So I went ahead and 3D printed, just in PLA, the final part that we're going to get after it's cast and then after it's machined to size. And this is just to make sure that the holes line up, that the height looks right, that the tool post fits on it, and everything looks good. So I've got some screws here, and we'll just go ahead and mount this on the machine. Might as well run the screws in, get an idea of how everything's going to fit. Now this is the big win for 3D printed prototypes, because I can put this on here, I can see if the screw holes line up, I can see how deep the screw heads are going to be in the machined features, and I can really get an idea aesthetically of how this is going to fit on the machine. So we can bring this up, and my goal was to have this so that this surface would be flush all the way through, so that if we cleared something spinning in the lathe with the tool holder, we would also clear it with the cross slide. Yeah, lining this up with a 1, 2, 3 block so that this surface is flush with the side of the cross slide. I'm pretty much centered in the boss there, and I think that looks pretty good. Let me just make sure that I'm close to being on center here, or at least I can reach center, make sure that all looks good. Yep, and I'm a little bit below center with this, and I still have a little bit of space I can go down. So I think this is going to work. Let's go make a 3D print of the pattern so we can send it off and have a real one cast. We want the smoothest surface finish possible on the 3D printed casting pattern so it will extract cleanly from the sand mold. So I'm going to print it on a Resin 3D printer. The printer that I have that I'm going to use is an Elegoo Mars 2 Pro. And so I've got the Chudabox software up here that comes with it, and we'll just bring in the model. And as you can see, this model is really large for this printer. I think if we tilt it up 90 degrees, it will fit within the printing area. Now, the next challenge is we do not want to print this thing solid. If we print this solid, it's going to use about a half a kilo of resin, and we'll never get it cured all the way to the center. So I want to hollow it out. So we'll go up here and click on the hollow button. We'll set it wall thickness, 2 millimeters is fine. Infill density with a grid to kind of support those 2 millimeter walls at 25% is fine. And we'll click start. And this will just go through and go down layer by layer, setting it up so that it has a grid to support the hollow shell on the inside. Okay, and that's what we want. It's hollow. You can see the screw hole is in there, and it looks like that is going to be supported well by the grid. I can live with that. Now, the other problem, of course, is if we print this, because it's being built up out of a vat of liquid resin, this thing is going to be completely full of uncured liquid resin. We don't want that. We want that to be able to drain. So come up here and click on the dig hole function, and we'll set 3 millimeter hole size, 2.5 millimeters deep. That'll go through the 2 millimeter wall. Add a hole, and I will just try to find the corners here. Now, if I click too far over so that it's not going into the hollow part of the model, it won't take. So I can kind of move this back, clicking as I go, until it punches a hole to get it as close to the corner as I can. Somewhere up here. Come on. There we go. There's a hole there. And then I want to put 2 holes in the bottom as well. Come on. There we go. Okay, so those are just going to act as vent holes. I think the reason it wouldn't let me put it all the way over here, hit Control Z and try again. Is that just because there's something over there? Nope, I don't know why. So remember, this is going to be printed upside down, hanging from the build plate. And so we need to make sure that we have vent holes on the top. Otherwise, this will act like a suction cup and it will fill up with resin and it will stick to the plate. But if we have these vent holes on top, it'll allow air in and allow the resin level to lower. And then, of course, we want them all the way down at the bottom because we're going to have to rinse that out. So we'll need them on the top and the bottom so we can get the alcohol to flow all the way through the part. Okay, that is the model. Now, I also am going to want to plug these holes. So I have my drain hole plugs here. I will just bring in that model for the drain hole plug. Now, this is just a tapered part that I modeled up in Fusion 360. It just tapers from 2 millimeters up to 4 millimeters. The idea being I can just glue it in the hole and trim it flush. Let me just move these over so that they're kind of all in one place. Yeah, this will be fine. They'll be out of the way here, right? Because they won't be underneath the model. And now we need to generate support. So I'll go ahead and select all here. We'll go over to the support tab. I've got this set to medium. The density is set to 80%, and I will just say plus all and let it just add everything that it thinks it wants. And then we'll take a look at what it did. Okay, so for the most part, this looks okay. I definitely want more than a single support point on these. Come on. This thing kind of wanders around when you click. I want at least 3 on each one of these. Okay, and then I want to see what this is going to look like when we start building. So when we come up from the bottom, just use the cursor key to go 1 layer at a time. And then I want to see what that first printed layer looks like and make sure we've got support on it. And we do. We've got support all the way out to the ends of that. And as we go up, it expands. We very rapidly start hitting the others. Yeah, that looks good to me. Okay. I think that is going to be good to go. So let's go ahead and slice it. Go back over here, hit slice. Okay, that looks reasonable to me. Let me save this and send it to the printer. Now that the part is out of the printer, we just need to wash it. So we'll dip it here in the alcohol bath. Now normally, we just have to wash the outside, but as you can see from the bubbles, this part is hollow and we need to rinse the inside. So it's filling up with alcohol from the bottom and the air is escaping through the vent holes we put in the top. We'll just go ahead and run the wash cycle to wash the outside, and yeah, it looks like it might be about time for some fresh alcohol here. Now once we've run that through the wash cycle and we pull it up, you can see that the level in the tank has gone down because the part is completely full. We'll just hold it here for a couple minutes, let it drain completely, then dip it back in and let it refill. And I'll just repeat this a few times, letting the part fill and then draining it out just to wash as much of the extra resin that's uncured out of the inside of the part as possible. Then we'll just take it off of the build plate with a spatula, break off the support material, and put it in the UV curing machine. And once this has been fully cured, it will be safe to handle, and we can take it out to the workbench in the shop and get it ready for actual casting. And there's the part right from the printer. I gotta say that text just turned out fantastic. Now, technically we could take this right to casting, but there's a few things that I want to do. For starters, since we printed a 5/16 18 thread in here, I would like to make sure that it is right on dimension and cleaned up. So I've got a 5/16 18 tap. And I know that the threads off of this printer are just a little bit tight, but they're actually quite good. So I will just run the tap in by hand. There's really no need for a tap wrench. They're really that close. I just want to shave it down because I don't want to run the risk of splitting the plastic when Clark actually screws the extraction rod in here. And that is the threads cleaned up, so the only other thing we need to do is we need to plug these holes just so they don't fill up with sand and grab at the mold and break it. Of course, I've got these little tapered pieces. Just break those off, make sure they fit in the holes, and then we'll just put those in with a little bit of glue. This is just a CA glue, it's Loctite 414, but any super glue will work. This is just, oh my. This is just what I happen to have in my toolbox. We'll just go ahead and put that in and let that cure. I spilled super glue all over my bench. By the way, if you spill super glue on your nice white workbench, acetone will clean it up beautifully. Just in case that's a concern. Okay, the glue's set there, and I can just come back with a pair of flush cutters and trim that. I'll trim it close to flush, and then we'll come back with sandpaper and smooth that out, and do that for the other 3 holes. And that's really all we need to do. This part would be just fine. It's got a few little rough spots here from where the support was. I'll go ahead and hit that with sandpaper just to smooth it out and make sure that we get a nice clean surface on the casting and that there's no roughness there that will grab the sand and again break out the mold. And then I think I'm going to go ahead and shoot this with a coat of paint. I've had pretty good luck with this Rust-Oleum gloss protective enamel. This is just gloss white. We'll put on 2 or 3 coats a few minutes apart just to get a nice, good, level layer of paint on this. Set it out in the sun in the 100-degree weather for a couple of days, and this should have a nice, hard enamel coating that won't abrade easily from the sand, and the sand should let go of very easily when Clark rams up the mold. And I think that's it. I'll get the paint on this, get it sent to Clark, and we'll get our part back in cast iron so we can continue this project. If you enjoyed this video, give it a thumbs up. Feel free to subscribe to the channel and leave me a comment. I'd like to know what you think. Thank you for watching.